and presented numerous papers in the area in national as well as international journals and various conferences. Professor Nuraida also actively provides trainings on food microbiology and safety for food industry and government institution. She is also involved in developing guidance for the production of safer food for small enterprises, food vendors, and school canteen under the coordination of the National Agency for Drug and Food Control, Ministry of Health, and Ministry of Education and Culture. Professor Lilis Nuraida, time is yours.
Thank you, Professor Ratish. Good afternoon, distinguished participants. First of all, I would like to thank the organizing committee for providing me opportunity to present my talk today. Let me share my presentation. Okay, just checking, anybody can see my presentation?
Yes, it is.
Okay,
okay.
Thank you.
Good.
Okay, so this afternoon, I would like to present a topic as mentioned by Professor Rati, the moderators. It's about gut microbiota and health, current and emerging applications of probiotics, prebiotics, and synbiotics. So what I'm going to talk today is I will start with gut microbiota and well-being and applications of probiotics in preventing gut disorder and also emerging applications for preventing diseases beyond gut function. And also a little bit, I'll explain a little bit about the development of probiotics to Biogenics. And I would like also to introduce a new term, next generations probiotics. And I will close my talk with challenges for future application. So basically what I'm going to talk today is the A to Z about the probiotics, prebiotics, and synbiotics. Okay, in the last 10 years, the associations between gut microbiota and health has been studied extensively. The relations between gut microbiota and well-being dates back to the observations of Professor Ilya Mesnikov. So he's called as a grandfather of probiotic. Based on his observation that the gut consumption of fermented dairy products with lactic acid bacteria, especially such as yogurt, was associated with enhanced health longevity in elderly Bulgarian people. Some of the bacteria present in the large intestine were source of toxic substances that contributed to illness and aging, what we call it today as pathogenic bacteria. Acid-producing microorganisms in fermented dairy product, especially lactic acid bacteria, may have an impact on the colony in the situation in which some sort imbalance exists that could lead to prolongation or sort imbalance that could lead to the state of a pathogenic state. The scientific rationale for health benefit of lactic acid bacteria in the preventions and treatment of the infection was provided in his book published in 1907, which is translated into English in 1908, entitled The Prolongations of Life and Optimistic Studies. So his observation actually laid the concept for a basic concept of traditional probiotics. Okay, although the probiotics area started by suggestions of Mesnikov in 1907. However, the term itself just introduced in 1953 by Collat, and then in 2001, the definition has been studied by the FAO and WHO, and in 2015, the International Scientific Associations of Prebiotic and Probiotics slightly modified the FAO definitions of the probiotic. So in 2010, this is the first human gut microbiology catalog established. So since then, there are many research or studied established the relations between the microbiota, the gut microbiota, and the health status. Okay, let's see what we have in our body and in our gut, gastrointestinal tract, or our gut microbiota. It is estimated that the human microbiota contain as many as 10 to the 14 bacterial cells with 3.3 million genes, as compared to the human cell present in our body, which is only quote unquote 10 to the 13 cells, only 1/10 of our human microbiota with 23,000 genes. Of the human microbiota, the 70% of microbiota are inhabitant of our gut. So the complete microbial genome has been done, and so showing that our gut is a home to over 100 to 1,000 microbial species that can be considered as an internal organ which primarily modulates the host intestinal environment. So the human gut is dominated by members of only 4 bacterial phyla: Firmicutes, Bacteroidetes, Proteobacteria, and Actinobacteria. So along our gut, the numbers and the diversity of our microbiota is increasing from the upper part of the gastrointestinal tract to the lower part of gastrointestinal tract. And the probiotics, what we are talking about today, mainly reside in colon. Okay, let's see the functions of healthy gut microbiota. The human gut intestinal tract, or the human gastrointestinal tract, has a nutrient-rich environment support for commensal microbiota that, providing some crucial functions, contribute to our health status. The functions of gut microbiota could be classified into 3 functions. First is a protective function, such as for improving barrier and increasing the resistance to colonization of opportunistic pathogens, as well as secretions of antimicrobial agents. And the second function is a metabolic functions, or colonic fermentations and productions of short-chain fatty acid. And the third is structural function, for example, by producing or maturation the intestinal epithelium and the immune system. The gut microbiota, they have here, influence many areas of human health, from innate immunity, appetite, energy metabolisms, and producing beneficial metabolite. So their role is very important for our well-being. The change of gut microbiota will bring a certain number of effect on a distal organs. I will talk later on about gut-brain axis and gut-lung axis. So what is the gut-brain axis? It's a bidirectional communication or relationship between the big brain, which is our brain, and the little brain. And some researchers suggest that our gut is a little brain. There are many mechanisms in communication between our gut microbiota and our brain, starting from the signaling and also from gut microbiota to the brain by productions of immune mediators and microbial metabolites, for example, neurotransmitters such as serotonin, gamma-aminobutyric acid, and brain-derived neurotrophic factors, or BDNF, and production short-chain fatty acid. And the last substance is called as brain food. And from brain to the gut microbiota is by alteration in mucus and biofilm production, motility, intestinal permeability, and immune function. So an abnormal microbiota, by releasing inflammatory and also neuroactive molecule, result in change in cognition, behavior, and emotion. And alternatively, also stress can lead to the gut dysfunction. Gut-lung axis is less studied than gut-brain axis. So this biosis in gut microbiota is associated with lung disorder and respiratory infection. As well as also dysbiosis in lung microbiota is also accompanied by disturbances in gut microbiota, for example, because of the translocations from the microorganisms in lung to the gut, our gastrointestinal tract. Okay, so what the relation? Again, the gut microbiota and the health and the human gut gastrointestinal tract harbor taxonomically and functionally complex microbial ecosystem. A healthy balance stated by high diversity and abundance of microbial population in our gut, this is the term or the state of eubiosis. And this is also characterized by domination or prevalence of non-pathogenic bacteria, especially lactic acid and volatile fatty acid producing bacteria. Several factors such as diet, eggs, antibiotics, stress can affect the homeostatic equilibrium of the gut microbiome and lead to the dysbiotic state. And in this dysbiotic state, the gut will lose of microbial diversity and change to a pathogenic state of the gut. And this leads to disease, infection, disease and infection causing bacteria toxin, and also toxin production bacteria, which is dominated our gut. So the prevalent is pathogenic bacteria. So the dysbiosis in gut microbiome is associated by numerous health disorders such as inflammatory bowel disease, malnutrition, metabolic disorder, asthma, and other neurodegenerative disease. Okay, this picture shows you how the balance between good bacteria and bad bacteria. The gut microbiota provide essential capacities for the fermentation of non-digestible substrate, the substrate that cannot be absorbed, cannot be metabolized by upper part of our gastrointestinal tract, such as dietary fibers and endogenous intestinal mucus producing beneficial substances like short chain fatty acid. And a shift in a gut bacterial content and the interaction of metabolite produced by bacterial metabolisms of dietary component can lead to the negative effect. This is the negative effect in our left side, where the bad bacteria is dominated, and this is the state of the disease state, and in the right side is the state of the healthy, which is dominated by good bacteria. Okay, it's restoring from the state of the bad bacteria into the good bacteria is quite difficult, and more easier is to maintain the eubiosis status or the homeostasis status. So in the case of the perturbed gut microbiota there are three recognized method or strategy. First is by providing probiotics. That probiotic is a live microorganisms that when administered in adequate amount will confer health benefit to the host. And so the probiotic can be used to restore the normal balance of the intestinal ecosystem as a novel health promoting strategy. But not all microorganisms could be considered as a probiotic. However, all the microorganisms that could be used as a probiotic have to go through evaluation in vitro, in vivo, and clinical trials to prove their beneficial effect. Other strategy is by providing prebiotics. Prebiotic is a substrate that is selectively utilized by host microorganisms, conferring a health benefit. Or you can also use the strategy by providing a combinations between both, between probiotics and prebiotics. Okay, originally probiotics were isolated from healthy human. However, the recent research saw that many sources, including fermented food, could be used as a source of the probiotics. Probiotics mostly belong to a limited list of genera, basically from Lactobacillus and by Bifidobacteria. Many of them has been grasped and listed on QPS in a European country. And what we have to remember that probiotic properties is strain dependent, meaning that not all species or strains are equal, And when we have a product with lactic acid bacteria, not all are equal. For example, not all yogurt are equal, or not all fermented foods are equal. This is just an example, list of the probiotic microorganisms that has been grasped and has been used commercially. However, there are many others lactic acid bacteria that have been permitted and being used commercially, including non-lactic acid bacteria such as Saccharomyces cerevisiae and Bacillus coagulans. However, those bacteria outside lactic acid bacteria is still very limited. Okay, what is the beneficial effect of probiotics? We can classify into three big main effects. First, for balancing gut microbiota. This is quite well established by maintaining intestinal microbial composition. And then the third function as immunomodulations to improve resistance to allergy, for example, stimulate the innate and adaptive immunity and prevent respiratory diseases. And the third function is by providing metabolic effect, for example, by secreting enzymes, for example, lactase or beta-galactosidase. This is very important for us as an ASEAN, because in ASEAN, the prevalence of lactose intolerant is very high, which is different with the European people. And also the probiotics, some probiotic producing bioactive compounds to, for example, for hypotensive effect, peptide, for example, and also conjugated thyroid acid, gamma aminobutyric acid, and also some neuric chemicals, and also some others beneficial effect resulting from metabolic effects. Okay. As I mentioned before, and in the last 10 years, there are huge and extensive research on the gut microbiota, on the association between gut microbiota and health, as well as on the functions of the health beneficial effect of probiotics. So there are establishing and promising effect intra and intestinal and extra intestinal benefit of probiotics. Firstly is the one that already established is in maintain the digestive health. For example, as I mentioned before, by preventing lactose intolerance and some others infective disease, especially the one related directly related to the digestive. And also recently, also there are many research about the functions of the probiotic on cardiovascular diseases, for example, by producing anti-hypertensive peptides and also to manage modestly elevated cholesterol. And also the relations between providing administrations of a probiotic with the mental health, for example, to preventing or anxiety and stress, and the function of probiotic as immunomodulatory, as well as in respiratory and prevention viral infection through immune system and reduce risk atopic dermatitis. This one is also related to the immunofunction, immunomodulatory. And others, which is already also emerging lately, is by providing probiotic to manage diabetes and also obesity. Okay, so what the distributions amongst probiotics which have this different type of mechanisms. First, the widespread among studied probiotic is the one that's already established: colonization resistance, acid and short chain fatty acid production, as well as regulations of intestinal transit, normalization of perturbed microbiota, and increased turnover enterocytes and competitive exclusion of pathogen. This one is directly provide health beneficial effect into intra gastrointestinal. And frequently observed among strains are for vitamin synthesis. Although we know there are some probiotics bacteria able to produce vitamin B complex and other vitamin, however, it's not distributed or among strain, it's not common among strain. And also direct antagonisms, gut barrier reinforcement, by self-metabolism and others activity, including neutralization of carcinogenic. This one is only frequently observed among strains. And this one is very emerging, and the research just started lately, is the beneficial effect on neurological, immunological, especially not only in the gut, but also in distal organ of the human body, including endocrinological effect, and also production of specific bioactive. This one is only present in only a few strains of a given species. So again, that not all function is shown, but all probiotics. So each probiotics has different specific function. Okay. First, the one that is how the mechanism, how the probiotic could prevent gut disorder. Actually, there are mechanisms that we already know, that the production antimicrobial substance, competition for nutritional substrate, competitive exclusion, enhancement intestinal barrier function, and also immunomodulation. Okay, and probiotic also could affect into the immunomodulations by, especially the probiotic antigenic fragment, for example, cell wall, are able to cross the intestinal barrier via intestinal epithelial cell and M cell, and they are processed and presented to the immune system and modulate the innate and adaptive system. So this function later on will also lead to the introduction of the new term of the probiotics. Okay, how about the application in beyond gut function? As I mentioned before, that in the gut function they already established. However, lately there are many research also showing that the probiotic also could be used to prevent, especially to prevent the disease beyond gut function. First, let's see the cardioprotective effect of the probiotic. There are at least two mechanisms. One is producing anti-hypertensive peptide. This is in the fermented food. I think in Japan there are already commercial drinks that can help in lowering hypertensive. And this one is peptide. The function is by blocking angiotensin converting enzyme 1. So the ACA will generate short peptides or tripeptide, only 2 to 5 amino acids with the molecular weight small, less than 5 kilodaltons. However, some others also found that could be from the quite a longer peptide with 220 amino acid. And this peptide mostly derived from the casein as a mother protein, which is present in milk. So different substrates could give different hypertensive effect. And the second is reducing cholesterol. First is we know it as a direct by assimilating cholesterol by bacteria, binding into the cholesterol or converting into other substrate, and indirectly by deconjugating bile acid or inhibition of enzyme synthesizing cholesterol. Okay, how about the probiotic and obesity and also type 2 diabetes mellitus? The pathology of obesity is multifactorial. However, there are some conditions such as low-grade inflammation and oxidative stress that seem play a special important role in the progressions of the T2DM. So the dysbiosis state could lead to the modulations of gut permeability and to low-grade inflammations and to insulin resistant and T2DM. The modulations of gut microbiota by probiotics will influence on glucose and fat metabolism, improve insulin sensitivity, and reduce chronic systematic inflammation. There are many other mechanisms that not has been established, so it's very often for research to establish this mechanism. One of our research showed that the lactobacillus rhamnosus reduce blood sugar level through down regulations of gluconeogenesis gene expression in streptozotocin-induced diabetic rat. So the mechanisms is that the probiotic, the probiotics, the probiotic don't regulate the gene, which is the gene is very important to produce enzyme, which is converting glucose 6-phosphate in our liver and then secreted into the blood. So this expression is down-regulated by the presence of the probiotics. And also lactic acid bacteria decrease pathogenic bacteria and then decrease inflammation, so indirectly decrease blood sugar. So in the food, lactic acid bacteria produce alpha glucosidase inhibitors and also antioxidant activity, which is when we consume will decrease the inflammation. Okay, probiotic in preventing colon cancer. Cancer-promoting gut microbiota produce carcinogen and tumor promoters for colorectal cancer. So the potential mechanisms of by probiotic is by binding or degradations of potential carcinogens, stimulations of productions of anti-tumorogenic compounds such as short-chain fatty acid and ferulic acid, and immune system modulations and modifying gut microbial balance. So from the state of the cancer balance, for example, this one and this in the left side is healthy balance, by providing probiotic is helping to shift from this state into the healthy state by returning from the dysbiosis state into eubiosis. Okay, probiotic in preventing neurological disorder. So as I mentioned before, that alteration in gut microbiota composition may also lead to the association with the various neurological disorder, including stress, autism, depression, Parkinson's disease, and Alzheimer. So the microbial compositions in gastrointestinal tract between those people suffering from the neurological disorder with the normal people are different, and this dysbiosis is observed in the people with neurological disorder. So administrations of probiotic has on partially or completely restore perturbation in commensal microbiota, so indirectly alleviating a variety of neurological disease symptoms. Okay, probiotic and respiratory infection. In respiratory tract infection, the majority of probiotic can inhibit the most important respiratory viruses by immunomodulatory mechanism, which is the mechanism is different with the one in the gastrointestinal tract, because the probiotic is consumed and reside in our gastrointestinal tract, could not directly contact with the microorganisms infect the lungs or the respiratory, the one that are causing respiratory tract infection. This antiviral activity also, of course, depends on the strain specificity and the situations of the host immune system. Certain strains of Lactobacillus and Bifidobacterium have shown strong antiviral against activity respiratory viruses, in particular, again, influenza virus type A. So this is showing you the meta-analysis of the effect of the probiotic for ventilatory associated pneumonia and upper respiratory tract infection. So the conclusions of this meta-analysis that probiotic are promising in reducing the durations and number of upper respiratory tract infection and the incidence of ventilator-associated pneumonia. Of course, depend on the strain. Okay, the next question is the recent development is by using single strain and also multi-strain. Which one better? Are multi-strain better, or this multi-strain better than a single strain? So the potential benefit of using multi-strains is by giving more chances of success for beneficial effect of the product, and of course lead to a larger success rate for a given health benefit. And also by using multi-strains, provide a greater diversity and thus more potentials and broader efficacy spectrum. And the effect could be additive or synergistic, and for example, enhance addition and creations of a favorable environment and reduce antagonisms of endogenous microbiota. However, to be able to be combined as a multi-strain, we have to see a potential negative effect. This is antagonistic effects between the combined probiotics. So for the multi-strains of the probiotic, we could also assess the compatibility between strain, not killing each other, however, by provide any synergistic or additive effect. Okay, let's see that, as I mentioned before, that diet is also could affect the could shift from the eubiosis into dysbiosis. So the dynamic relationship between the microbiota ecosystem and its host is emphasized actually the joint utilization of consumed nutrients. Diet could be a substrate between host and the gut microbiota. And also the choice of diets could affect host health both directly or indirectly by affecting the abundance and composition of the microbiotic community. For example, food rich in fiber, polyphenol, and non-digestible polysaccharides will give or will improve the microbial diversity, so toward to the more beneficial microorganism, and also alter the microbial metabolites, for example, short-chain fatty acid, bile acid, and also trimethylamine and others. So finally, the outcome is the health impact. So the substrate that utilized by a probiotic or by beneficial microorganisms we call as a prebiotic. So recently, ISAPS redefined the prebiotic as a substrate that is selectively utilized by host microorganisms conferring a health benefit. Okay, this definition expands actually the concept of prebiotic to possibly include non-carbohydrate substances, which is applied to modulate the microbiome diversity in our gastrointestinal tract. So, but currently the probiotics established is from a dietary fiber, but not all dietary fiber is a probiotic. So the probiotic that has, yes.
Prof, I'm so sorry, but time, please. Do you still have more? Only 5 minutes.
Okay. So yeah, I will show quickly. So this one is readily fermentable. So by this definition, actually, not only non-digestible polysaccharide, but also including polyphenol and also conjugated tonic acids. Okay. Okay, this is the prebiotic mechanisms. So shifting from the gastrointestinal tract function, from immune pathogenic immune stimulation, also to cardiometabolisms, mental health, also bone or mineral availability. This is the example how prebiotics and bioactive compounds could be used to improve the diversities of the microorganisms and effect on health outcomes. Okay, this is, I'll just skip the natural sources of probiotics, but lastly is the symbiotic. Symbiotic is a mixture between probiotics and prebiotics. So just recently in August 2020, ISAP also defined a symbiotic is a mixture comprising live microorganism and substrates selectively utilized by host microorganisms that confers a health benefit on the host. So what is the host of the microorganism is what we call it autotonous, the one that resident or colonizing the host, and allotonous, which is the one externally applied, such as probiotic. So the subset of probiotics right now is the complementary symbiotic, the subset of symbiotic, complementary symbiotic, and synergistic symbiotics, depend on the purpose. The one that complementary is actually prebiotics and probiotics, that the one synergistic symbiotic is prebiotic only to provide food for probiotic. However, complementary symbiotic to also provide food for autonomous microorganism. Okay, this one is example of symbiotic. So my last talk is from probiotic to biogenic. So the explosion of new term driven by the functions of probiotics and related substance beyond gut health has derived many new terms from synbiotic, paraprobiotics, postbiotic, and many biotics, including next generation probiotics, and all this term is called as the biogenics. So product made by or of life forms, including secretions and metabolites. So as I mentioned before, that some functions also solved but by not live probiotic, but also by dead or non-feasible probiotic. So this one is called paraprobiotics, which is sometimes called as a ghost probiotic. and also by microbial metabolites produced by probiotics, and also the microbial cell walls component. So this one is called as postbiotic. So this one could be related to the health functions of the fermented food, that one that maybe there are no live microorganisms, but also there are some microbial metabolite. So what is the next generation probiotics? If you see these figures, that a probiotic usually long history of use, for example, Bifidobacterium, etc. However, next generation probiotic or live biotherapeutic products, no history of use, for example, Akkermansia, Bacteroidetes, and Faecalibacterium. But these microorganisms, some research has shown that when administered in adequate amounts, confer a health benefit on the host similarly as probiotic. And they use probiotic mainly in the food and the supplements. However, for the next G probiotic and live biotherapeutic products is mainly used as a medicine. So my last slide is challenges in future probiotic application. That we know that the benefit of probiotic has been expanded to the site other than gastrointestinal tract. And also growing awareness of potentially beneficial effect of probiotics and increased consumer interest in controlling their own health. So this also lead the challenges for the researcher to further investigate the mechanisms behind the attenuating effect of probiotic to increase their applicability, a single or multiple strain, new strain with specific function, and characterization of the substance produced by probiotics. Similarly, for the challenges for the industry, to increase probiotic in global market and substantiate the health benefit, general or specific, and characterization of the probiotic product and technological aspect, and also to meet the consumer demand. But all this has to be supported by regulatory, clear guidance, and also maybe harmonizing regulation is also needed. Okay, that's all my presentation. Thank you very much for your attention. I'll hand it back to Professor Ratih as a moderator. Thank you very much.
Thank you, Bu Lilis. Thank you, Prof. Nuraida. It was a very enlightening talk. I hate to cut short your talk because it's so interesting. And there are so many questions in the chat box. So please continue writing up. The organizer will select some of those to be questioned in the end of the session. Now I would like to introduce you to our next outstanding speaker, Professor Chin Kun Wang, who will entertain us with his talk on process development of functional foods. Professor Chin Kun Wang is Distinguished Professor in Chung-Shan Medical University, Taiwan. He is also the former President of the International Society for Nutraceutical and Functional Foods, ISNFF, Fellow of International Academy of Food Science and Technology, ISNFF, Honorary President of Nutrition Society of Taiwan, and Chair of Global Incident Alert Network Global Harmonization Initiative. Professor Wang got his MD and PhD degrees from National Taiwan University and joined Chung-Shan Medical University in 1993. In 1996, he was promoted as full professor and then took the positions of the chair, dean, vice president, and president in Chung-Shan Medical University. His research work focuses on human clinical trials and human metabolisms of medicine, nutritional supplement, nutraceuticals, herbs, and functional foods. And in 2008, he got the National Award of Biomedicine for his great contribution to the medical education. Prof. Wang was also honored as 2012 20 Who's Who in the World, Who's Who in Asia, and 2011-19 Who's Who in Medicine and Healthcare. In food safety and nutrition area, he promoted the legislation for school sanitary law and national nutrition law. During the food safety problem in Taiwan, he joined as the director of ILSI Taiwan and chair of Global Harmonization Initiative to communicate with the media and press. He believes that scientific evidence is the best support for food safety and world nutrition problem. In the future, he's trying his best to work together with the scientists around the world through his international network. Professor Wang, time is yours.
Okay, thank you. Thank you for your very kind introduction. Ladies and gentlemen, it's my great pleasure to join this conference. I wish everybody is safe and keep good health. Because of COVID-19, we cannot face-to-face. However, I think virtual meeting is the best way. Today, I would like to share all of you is about the process development of functional food. It's fine. I will control the time. Yeah. All right. As mentioned earlier, for example, Professor Lydia also mentioned about the importance of probiotics and prebiotics. Actually, is evidence-based. So today I would like to introduce is about the process development of the functional foods. Yeah, as the introduction from the chair, I'm Chin Kun from Taiwan. Okay, at first, why functional foods are so popular? Because it's the demands for the health and preventive medicine. Yeah. So recently we know that NCD, that is non-communicable disease and health, they have a very close relationship. So this is also the reason why the CAN, that is the complementary and alternative medicine. Actually, in 1997, the National Center of CAN was established in the United States of America. Yeah, basically, we know non-communicable disease is not infected just like COVID-19. It is from the lifestyle and also dietary behavior and so on. So usually you can see different kinds of NCD, for example, the gout and hypertension, and also some joint problem, and also metabolic syndrome and obesity. All right, so as we know, diabetes is a very serious problem around the world at this time. Diabetes, this is basically no syndrome, and also no important, it's not so clear to have some specific performance. However, the derived disease are very serious. For example, the wound healing problem, usually with the people suffer from the diabetes, usually the blood circulation is a big problem. So the wound healing is very serious. And also because of the glycation, so the cardiovascular disease is also very serious recently. Yeah, so this is the reason why the global plan of action in 1992 Rome is that everyone has right to get nutrition and good and safe foods. And nutrition is closely associated with the social development, and it is also the target of human progress. All right, so here we can see is about the WHO resolution and strategy. So basically, to treat this kind of problem, the diet and physical activity are the most important issue with health. All right, every time we mention about the nutrition deficiency and health, I can list some important points. For example, the overweight, obesity, or low vegetable, fruits, and dairy intake, or low vitamin B1, B2, B6, folic acid, magnesium, potassium, and also low calcium, high protein, lipids, and low carbohydrate intake, and also high sweet drink and fried food. So the nutritional education and environment are very important for the nutrition improvement. So what is so-called nutrition? Many people are confused about the nutrition are only vitamins and minerals, but you know, vitamins and minerals, they are only minor nutrients. The major nutrients are carbohydrate, lipids, and protein, but they are all, they are not so-called all nutrients because we also can get some phytochemicals from nature, from plants. Yeah, so we can see different kinds of nutritional supplements and also different kinds of functional foods in the market. So for health, from individual to community, I think education, policy, and also very good dietary behavior are very important. So this is the chance for the functional foods. CAM, as I mentioned earlier, is a group of diverse medical and healthcare systems, including the practice and products, and not generally considered part of the conventional medicine. As we know, herb, acupuncture, magnetic treatment, functional food, nutraceutical, all of them belongs to CAM. And the most important, that is evidence-based. Yeah, of course, the safety and effectiveness are very important. So from here, you can see from the past till now, no matter in United States, Europe, even Japan, or the South Asia area, the dietary supplements are very popular, and also a lot of the business around the world. All right, so the definition of healthy food in USA, they have a term that is the dietary supplements. So they have very clear statement of any product taken by mouth that contains the so-called dietary ingredients, and its label clear states that it is a dietary supplement. The dietary ingredients may include vitamins, mineral, herbs, and also different kinds of extracts or concentrate. So for the management of functional food, I think one thing is very important. Is evaluated by FDA, but this product is not intended to diagnose, treat, cure, or prevent any disease. So this is quite important. This is functional food, it's not medicine. So different kinds of claims in the United States. For example, the structure function claim. I take an example of calcium. Calcium builds a strong bone. It belongs to the structure and function claim. If calcium may reduce the risk of osteoporosis, this belongs to the health claim. If calcium will prevent osteoporosis, this is the drug claim. So in different area or country, usually we have different managing system. For example, in Japan, Taiwan, and mainland China, we usually have this kind of logo, and after getting the scientific evidence, they can get the logo and they can sold in the market. So the next, I would like to recognize what is so-called functional food, what is nutraceutical. They seem to look very similar, but actually the definition is different. Usually functional food is still food type and common use, including animal, plants, and microbial organism. So for example, the oatmeal, yeah, is some kind of functional food, still a food type. But for the nutraceuticals, is not original food type. Usually the powder, tablet, or even a capsule. So the appearance sometimes look like medicine. All right, so the definition of healthy food in Taiwan actually is also very similar to United States. We always say that providing special nutrient or health benefits claim or label on food. So the purpose is not for disease therapy. Okay, so before the identification of functional food and nutraceutical, the toxicity and functional should be determined first. About the safety evaluation, of course, we have to pass first. And always, we can use the microbiome and animal system to improve the safety evaluation. And about the functional evaluation, I think usually we have two ways. One is by animal system. The other is by human clinical trial. Sometimes both the animal and human clinical trial design. All right. Before the study, usually we have the preclinical trial. Basically, the name should be only discovery. From the preclinical trial, we can understand the molecular structure, the best combination, and also screen the design, cluster analysis, discriminant analysis, factor analysis. So sometimes by animal, we can also find the dose-related response, and also we can understand the pharmacological activity. But I have to say, this is only a basic research. It's only discovery. So most laboratories, your discovery, your research is focused on discovery, and for advanced use of this kind of functional food or nutraceutical, we need to do some advanced study. So if you have the discovery and next step, of course, we have to understand how is the toxicity. So we have different kinds of evaluation way. For example, the genetic toxicity, animal toxicity, reproductive toxicity, carcinogenic toxicity, and also dose relationship. Yeah, after that, what we can do, that is ADME. What is ADME? From absorption, distribution, metabolism, elimination, and also finally, we can decide the formulation. Okay, about the formulation, basically is how to reach site of the action. For example, tablet, capsule, powder, liquid, lotion, cream, gel, and so on. And then we can move in to next step. That is investigational new drug application (IND). This is for clinical trial. When we move into clinical trial, usually includes 4 phases, from phase 1 to phase 4. So phase 1, usually we will include healthy participant subjects, and usually in the age of 30 to 40 years old. N value is about 20 to 80, and the purpose is to get the time to maximum concentration, Tmax. Also the maximum concentration, Cmax. And also we can get the area under the curve, and also bioequivalence and bioavailability. For the phase 2, of course, we usually enroll the patients. We have to make sure the safety, efficacy, and the most important, we can get the dose ranging in phase 2, and also get some other pharmacological and pharmacokinetics. Okay, for phase 3, usually this is adequate and well controlled. We need the pivotal placebo-controlled study, and always we also need the active control study. And of course, for phase 3, we can further evaluation for the safety and efficacy, and we have 2 ways. One is short term, the other one is long term. And also we need to include the elderly or liver and kidney patients. So after phase 3, usually that is associated with the new drug application, and also try to commercialize, and also the statistically valid. All right, this is for phase 4. Phase 4, that is after commercialize. So we can get some adverse events in phase 4 study. And of course, we can also get some pharmacological effects, and also how is the influence on elderly, child, pregnant, and also get the morbidity and mortality, and also identification for new purpose. So the all kinds of experimental design, the most important rules are the 4. The first is identity. The second is strength. The third is quality. The last is purity. So the parallel and crossover design. These are often used in clinical trial. For ASICs, usually the crossover is much better than parallel. But the crossover, because the time is very long, they have the crossover period, and also need a washout period. But the subject is very easy to drop off. So it's not so easy to do. Yeah, and the time is also long. So usually for crossover, we will involve in phase 1. But for phase 2 to phase 4, usually I suggest we can use the parallel design. The next is about the single and multiple center trials. Most by multi-center trials is better because it's easy to enroll subjects. So for example, in my laboratory, we usually have the multi-center trial, just cooperated with different medical centers around the world. So it's easy for us to enroll the subjects. For the single center, it's difficult to enroll. For example, if we would like to enroll the confession heart failure, because the N value is very low in every medical center. Yeah, and also we need to notice about the center effects because the treatment by center interaction is also important issue. All right, the blinding and also open label. Usually, if the subjects, they do not know, but the researchers, they know this is so-called single blind. For double blind, the subject and also operators, all of them do not know. So finally, we have the so-called open label. Yeah. And randomized and non-randomized. Usually, I greatly recommend the completely randomized.
Organizer, do we lost him?
Yeah. Can you hear me?
No, it's okay, Professor
Okay.
Ratih.
All right. Okay.
Yeah, just continue, Professor Chin.
All right. Yes. Yeah. So usually we have the randomized block design. All right. So this is a placebo-controlled and active control. For phase 2, we can compare with the placebo control, but we can have a fewer placebo subjects than experiment. But phase 3, because of the ethics, we need to enroll the active control subjects. So as I mentioned so much, but the most important, that is evidence-based. Yeah, because the new hope of medical treatment, yeah, is a scientific evidence. But for functional food and nutraceutical, this is a big challenge because the quality of the raw materials, the quality control, that's very important for well-improved functional food and nutraceuticals. So next, I would like to introduce my university. I come from the Zhongshan Medical University. Yeah, it's located in Central Taiwan. Yeah, we have a very rich instruments. For example, a very new PET system, and also we have our own cyclotron center, so we can prepare the radio label materials in our hospital to treat the patients and our subjects. And we have very new MRI and also linear accelerator and tomography, gamma line, and so on. Yeah, for some treatment of our subjects, we can also use the hyperbaric oxygen therapy. Yeah, it's very effective for diabetes. This is for our human study. We have the laboratory medicine area, and this is nursing department waiting area. So in our university, we have different kinds of centers: CAM center, clinical trial center, IRB, toxicity evaluation center, R&D center, and incubation center. Our university is a medical center. We have 1,500 beds. Is a medical center level in Taiwan, the highest level. Yeah, so I will have an example about the evaluation of a ganoderma on liver. Yeah, so this is a very typical clinical trial. I just share all of you. Yeah, because we do some studies in our laboratory from the basic research and know everything about the ganoderma, and then move into animal and then to human clinical trial. So of course, this study is focused on how's the influence on anti-agent. Yeah, so we would like to see how to terminate agent, how to slow down the agent. Yeah, we know agent is a problem. Yeah, we can see the difference between the different generations, and agent is very easy to be recognized. For example, from the skin, yeah, we can recognize how is the agent situation. Yeah, and sometimes we also see how to recognize agent. Yeah, some people say that maybe the belt height If the belt is high, maybe it's Asian. Okay, and we also have different kind of indicators in our body. For example, from the eyes, the respiratory system, digestive system, and so on, and also dermatitis. All right, so this is so-called anti-aging pyramid. However, we also need the evidence. So I would like to introduce is about the growth of the Ganoderma lucida. Basically, it can grow very quick. Yeah, this is 16 weeks after inoculation, and here is 18 weeks. And just after 24 weeks, the end of the mushroom cap growth. So we can harvest at this timing. All right. Of course, for Ganoderma, different variety of Ganoderma, and of course, their pharmacological response is also different. But I have to say, Ganoderma is very highly used in Asia, and also is very mild of pharmacological effects, and also classified by different texture, color, and also had been used as a traditional herb. All right, this is the composition of the Ganoderma. The rich components like cellulose, and also lignin, water, and but we can notice here the polysaccharide and also some protophenolic and some protein. All right, so we can see the functional components in Ganoderma, including the polysaccharide and some specific protein, linseed, and also some nucleic acid and some special minerals. So, for example, the triterpenoids, they are bitter materials and also show different kinds of function. For example, the liver protection, blood pressure, and cancer suppression, and also anti-allergy, improve the liver function. This is the chemical structure of triterpenoids. And the other one is polysaccharide. Yeah, the polysaccharide in Ganoderma also show different kinds of function. For example, anti-cancer, immune promotion, anti-oxidation, and also promote the production of some interleukin. For example, interleukin 1, 2, and interferon gamma. Yeah, this is different types of polysaccharides. Yeah, so about the anti-aging and long life, we know they have some relationship, but I will get into the result and show you how is the influence of the Ganoderma on aging. Yeah, free radicals is a very good theory for aging. Yeah, so we will try to see how is the anti-oxidation and anti-aging during our study to evaluate Ganoderma. Yeah.
Professor Wang, you have 5 minutes, please.
Yes, enough. Yes, I will finish soon. All right, about the study design. This is a clinical trial. Totally is 13 months. Yeah, so every capsule, including the triterpenoids and also polysaccharide peptide. Yeah. All right, this is a crossover, 2 groups. The first group, they use the placebo first and 1 month washout, and then use the sample. The other groups use them sample first for 6 months and then wash out, and then they change the placebo. This is the clinical design, and you can see it's very clear. We can do different kinds of clinical evaluation. All right, so about the anthropometric measurements, basically after the intervention, no change among the experimental and the placebo groups. And we also determine different kinds of oxidant indicators. Yeah, so I will show you first. For example, for the antioxidant capacity of plasma, after the intervention of the Ganoderma, the antioxidant capacity will greatly increase, but the TVA value will greatly reduce. And we also measure the total cyan groups is also increased. Glutathione is very significant indicator. It's also increased after the intervention. Yeah, this is the DNA oxidative products, 8-hydroxyl guanine. We can see the levels will also greatly reduce. Yeah, we also measure different kinds of antioxidant enzyme. Yeah, so I will show you very quickly. For example, this is a superoxide dismutase. In erythrocytes, it's greatly increased. This is glucose phosphate dehydrogenase is also increased. Catalase also increased. Glutathione peroxidase is also increased. All right, very important clinical evaluation of liver. Yeah, basically we have to know this is fatty liver, normal liver, and here this is fibrosis liver. But after intervention, we can see no matter the GPT value or all the levels were greatly reduced. GOT values were also reduced. And we also did the exam, abdominal ultrasonic examination in hospital. We find something very interesting. The fatty liver subjects, after the intervention of the Ganoderma, all the fatty liver disappeared. Well, it's very interesting. And this is the gallbladder polyp, also disappeared after intervention of the Ganoderma. So actually, I do not repeat the conclusion, but one thing I have to say, evidence-based is very important. So, but because I have a very good team, including different departments in our university and hospital. So we publish a lot of paper. So this is the commercialized Ganoderma. You can find it in Taiwan market. And in my laboratory, we also have different kinds of studies about natural materials. For example, for the tomato phenolics, bovine serine hydrolysates, and so on. We also have some studies about the cancer therapy. Yes, so I think everything is evidence-based. I just showed with all of you. Now I have a big team. So our publication production is very high. Every year we have about 10 to 12 publication papers. Yeah, so this is the 2 years publication in my laboratory. So this is my team. I have several. Now I have 6 postdoc fellows from Russia, India, Pakistan, Bangladesh, and also 7 research assistants and PhD students and master students. So I know the time is very limited. I wish all of you can share some studies. Finally, thank you for your kind attention. I wish I do not delay any time. Thank you.
Thank you, Professor Wang. It's a very important information to provide evidence for assessment of safety and functionality of our functional foods. I think because we are running late today, I will only have like 15 minutes for a discussion, and I can see there are questions already in the chat box. Could organizer please show me some of the questions so I can read it to the speakers? Okay, I think I'm gonna start with one question for Professor Lilis Nuraida. The first questions, I'll take 2 questions first. Can probiotic reduce allergic response? Please elaborate. And what is the main mechanism in reducing obesity by probiotic? Do you suggest that, well, this is a bit different question. Do you suggest that all these people should consume probiotic regularly? I think I'm gonna stop at that one question. Is there any question for Professor Wang? Not yet. All right. I'll read the second question for Professor Lilis. What would happen?
Professor Wati, yes, there is.
Yes.
Could you please enter the slide, host?
Okay, so I can give each the same slot for answering a question. Okay, Professor Chin Kun Wang, there is one question for you. Can you please elaborate more on the utilization of in silico technique in functional food development? If it is possible, in which phase should it be involved? Have you done this in your research lab? And then probably one more. Can you specify the difference between functional and functional foods and food supplement in terms of process development? I'll stop at that. So everybody have one question. I can start with Ibu Lilis, Professor Lilis, please.
Okay, thank you, Bu Rati. Okay, I will answer the questions about the allergic response. So the question is that a probiotic can be used for the allergic. Yes, but certain probiotics, I mean, the response for the allergic is this correlated to the immune system, So the probiotic could suppress the one that involved in the allergic. For example, TH1 will be increased, but TH2 will be decreased. And also many others IgE immunoglobulin that specific to the allergic will be increased in the by administrations of the probiotics. But again, that specific probiotic, specific strain may also give different response to different people. So especially that the one with there are many other allergic, especially allergic. This one is related to the one with the food because there are so many allergic. Okay, I think that's my answer. And the second answer is about the autism. So this one is different. It's not the allergic, but the autism is related to the neurofunction. Okay, to the neurofunction, what so I mentioned is between gut-brain axis, where that the source of the problem is dysbiosis. The diversities and the abundance of beneficial microorganisms is decreasing. And whether the for the people with the autisms could be administered, could be given probiotics. Again, that yes, theoretically yes, you can, but at least by providing the probiotics, that the one is already proven that could be reside in the gastrointestinal tract and could also improve the diversity and the abundance of the microorganisms, beneficial microorganisms in our gastrointestinal tract that could be also help, maybe not curing, but help in autisms. That the probiotic is is not well, we could also know for the food is probiotic as functional food. It's not for curing. So more for prevention. Yeah, I think that's my answer, Bu Rati. Thank you.
Thank you, Prof. Lilis. I think that will be clarify some of the concern. And next, Professor Wang, would you kindly reply to that question?
Okay, sure. I think the first question about the silicone technology. Basically, functional food include different kinds of technologies. Yeah, so in my laboratory, because I have a big team, we usually have different cooperation with different countries. For example, recently we also have a cooperative program with Wisconsin medicine that is about gastric cancer problem. Yeah, we also try to find some natural materials and also a very useful delivery system. Yeah, so also try to analyze and also try to use different carrier to increase the bioavailability of some vital chemicals. So welcome everyone. If you have interest, you can join us. About the development, process development of the functional food. Basically, not only the biological research, of course, some processings are also very important. Yeah, but as for my major, we are focused on the biological and medical issue of the functional foods. Yeah, I believe in the food science field, it's very wide. Also, so many food technologies. Maybe your major are focused on some processing engineering. I think everything are also required in the future. When we combine them together, we can get more and push more. Yeah, thank you.
Yeah, thank you, Professor Wang. I understand you're emphasizing on the collaboration between health and food science to be able to develop a good functional food. I agree. Is there Do I still have time, Dr. Aziz?
Yes, Professor Rati, you may get one turn more.
Okay, one more, and please give me the slideshow for the question. So, okay, I'm going to, I'm going to go with question number 2 from Bakhtiar Hermawan. Question is for Professor Lilis. What would happen if I consume probiotics that can produce gamma aminobutyric acid, GABA, and the GABA is already inside the product? Is there any systematic review about intervention against disease by probiotics, especially in Indonesia? That's question for Professor Lilis, and I would like you to switch to the other slide, Dr. Aziz, so I can get one more question. I understand there is one more question for Professor Wang. Professor Wang, this is question for you. What do you suggest? Which is better to consume? Functional food or nutraceutical? When we know that consuming functional foods can be satiating, but not if we only consume nutraceuticals. Okay, that's the second question for both distinguished speakers.
Okay.
Prof. Lilis?
Okay, thank you, Bu Rati. Baik, okay. I forgot the question. It's about GABA, right? Consuming probiotic products with gamma aminobutyric acid. Yeah. Well, I don't quite get the question, but I could expand that the GABA is gamma aminobutyric acid is also a neurotransmitter, which is good for our brain. So when you consume probiotic, the one with known as GABA producer, is very good, and also when you have the GABA in the product is also very good. It could help, maybe will help to to maintain our brain, because you say, as I mentioned before, that the gamma aminobutyric acid is a neurotransmitter for the brain. Is there any study intervention in Indonesia, especially the one with the probiotic producing gamma aminobutyric acid? I could answer no, not yet. And as I mentioned before, that this probiotic strain that could influence or could have benefit, especially into the gut brain axis by producing gamma aminobutyric acid and neurotransmitter, is very limited, only certain strain. It's very different with the one that could survive in our gastrointestinal tract. So it's still progressing. Not to my knowledge, it's not a specific intervention study not done in Indonesia. Bu Rati, can I have I just read that the one that I think I have to make a comment on the other question. Yeah, I think that's very important, because this one is about where the probiotic reside. The probiotic is reside in the not in the kidney. Okay, not in the kidney. The probiotic reside in the colon. So any food, any polyphenol, for example, bioactive compound, which is not absorbed by our body, some of them could also be used by certain probiotics in the colon. So the one that absorbed by a human, for example, go to kidney or to go to distal organ, will not be used by probiotic. So the probiotic is not in the kidney. So it's not allow proliferations of the microorganisms in any distal organ. However, in the colon, in our gastrointestinal tract, as I mentioned before, maybe some probably in our intestine. I think that's very important to mention this. Okay, thank you, Bu Rati.
Thank you, Bu Lilis. I think it's good to straighten out. It's not supposed to be invasive to our organ. Good. And then a question to Professor Wang.
Yeah, sure. Okay. I have to say, everything is toxic, but the dosage determines the toxicity. Yeah. So even for medicine to treat a disease, if overdose use is also toxic. Yeah. For functional food, of course, the effective materials concentrations are much higher than normal foods. So the consumption amounts are very important. So this is also the reason why we need the evidence base. We need to know what is the best dose to promote or maintain the health. And if overuse, sometimes it's also toxic. So this is the reason why I mentioned about from the discovery, from the safety, and then from the functional evaluation, step by step, and everything. When we get the evidence, we can provide the information to the consumers to prevent the results we don't want to expect. But if we can provide very correct information, actually, it's very helpful to our health.
Okay. Well, I was just been informed that I can use another 10 minutes or 7 minutes. So if I can get my slide back so I can go to the question, Pak Aziz, Dr. Aziz. So that people...
Please, host can show it. Please, host.
Oh, can I? No. Okay. All right. So there are more questions for Professor Lilis. I think I'm going to just read it for you from Ibu Nur Hayati. Probiotic, if formulated in food or beverages, may also... Oh, this is... Oh, I think I got it. This is the question. Okay. So I think number 3 has been...
I was afraid I don't have time.
Okay. Yeah, I just learned that I have that extra minute. So number 3 has been answered by Ibu Lilis. So I hope Bu Nur Hayati already got it. And then the last question from Ibu Tati Kusniati. How far is the efficacy of probiotic against the diseases compared to the medicine? Okay, that's a question for Prof. Lilis. Is there any more question for Prof. Wang? I guess not. Yeah, I think both, the first one I think is already addressed by Prof. Wang. So please, Bu Lilis.
Okay, thank you, Bu Rati. I answered the third question. I'm afraid that I didn't have time, but it's very important to answer the third question. Okay, and the fourth question, as I mentioned before, that probiotic is not a medicine. So probiotic is used in food or as a supplement. However, now, as I mentioned to you, that we have next generations of probiotic, which is dedicated for a medicine. However, that's still in a level of the in the stage of the research. But more applications of probiotic, mostly in food for prevention. So when I mentioned the use of probiotic as a medicine, as what I call as emerging use of probiotic, which is still need a lot of evidence that those probiotic can use as a medicine. However, probiotic as part of the functional food. With probiotics, we could also call as a functional food. Okay, thank you, Brati.
Okay. Well, thank you, Prof. Lilis. I think we are about close to the end. I don't pretend to summarize because this is such a heavy materials, but what I can tell you is Ibu Lilis, Prof. Lilis has shared to us many basic science behind probiotic, prebiotic, and symbiotic, how it would affect or support our the eubiosis, how it can be used for versatile functional food, and there are a lot of prospective uses in the future. She mentioned several new areas such as the gut lung axis and then gut brain axis, etc. That will be probably very new area for all of the students in the future. And Professor Wang, thank you so much. You already enlightened us with how do we support, how do we push our local products to be able to have this claim as such a functional food. And it does need, we can hear from him, there are plenty of steps to be done, very many assessment for its safety first, of course, and then also for its functionality. I think Dr. Wang has a hospital and a medicinal apparatus, so they can study many of this. But I think in the future, maybe we can have some collaboration so that studies in the food part can be extended to the more biological function. Okay, with that, I think I will just conclude this session. It's such enlightening with a very experts in this field. Thank you so much, Professor Wang. Thank you so much, Professor Lilis. Thank you, the organizers, and also thank you for all of the participation. Assalamualaikum warahmatullahi wabarakatuh. I'll give it back to the organizer.
Thank you.
Thank you. Thank you all.
Once again, thank you very much for the insightful discussion, Professor Rati, and our keynote speakers, Professor Lilis and Professor Wang. Now we are going to take a group picture. So I would like to ask the host to highlight Professor Rati, Professor Lilis, and Professor Wang. Thank you once again for the very insightful discussion. I feel like I am now much more motivated to observe what I eat, Hanin, especially to choose functional foods for my daily diet.
I second that, Candice. Now, ladies and gentlemen, we have come to the most anticipated moment. I assume everybody is on their edge of the seats, Candice, because we're going to announce the winners of GSRPC, FPDC, and the best presenters for 3 parallel classes.
So we are now going to announce the competition winners of GSRPC.
Excuse me, can we have a break 5 minutes? MC, we are going to have break 5 minutes, yeah? We would like to make the presentation ready. Thank you.
Okay, sure. Thank you, Professor Sitangga. We're going to have a break 5 minutes, ladies and gentlemen. So please don't leave this meeting room because we're going to have the most anticipated moment after this. And see you at the next 5 minutes. Thank you very much. Ladies and gentlemen, we're back again with the most anticipated moments of today. So what do we have today, Candice?
Today, Anna, we are going to announce the winner of GSRPC and FPDC and also the best presenters for 3 parallel classes. First, we are going to announce the competition winners of GSRPC. The third prize of GSRPC goes to Yuli Perwitasari from Gadjah Mada University. And the second prize goes to Hadi Munarko from IPB University. Last but not least, the first prize goes to Inike Sintawati Mualidia from IPB University. Congratulations to all the winners.
Congratulations to all the winners. And now for the best oral presentations. In parallel A, the best oral presenter in the first term is Dwi Larasati Nurfibri from Gadjah Mada University. And on the second term, the best oral presenter from parallel A is Nijma Nurfadila from IPB University. And next in parallel B, the best oral presenter from the first term is Nindya Atika Indrastuti from Juanda University. And in the parallel B, also in the second term, the best oral presenter goes to Resha Shrestha from Assumption University. And in the parallel C, last but not least, in the first term, the best oral presenter goes to Nancy Dewi Yuliana from IPB University. And on the second term, the best oral presenter goes to Aziz Boeing Sitanggang from IPB University. Congratulations for all the best oral presenters.
Next, we are going to announce the winners of FPDC 2020. The winner of e-poster category is Aaron Karista Dea from Brawijaya University. And for the honorable mention of FPDC 2020 goes to Bram Ungu from Machung University. Next, the best innovation idea goes to Kermin from IPB University. The third winner is Mi Oikap from 11 Maret University. And the second winner is Udo Kirami from Brawijaya University. Last but not least, the first winner is Hemix from Bandung Institute of Technology. Congratulations to all the winners.
And last but not least, we are going to announce the winner of beverage category in FPDC. The honorable mention goes to Bring from IPB University. And next, the best innovation idea goes to Kombuto from IPB University. Next, we have the third winner of FPDC goes to High Five from Bandung Institute of Technology. And the second winner goes to Walucha from IPB University. And last but not least, the first prize goes to Gincha from Brawijaya University. Congratulations to all the winners. And ladies and gentlemen, please give a round of virtual applause. Once again, congratulations to all the winners of GSRPC, FPDC, and the best oral presenters. Best wishes to all of you, as you all deserve the wins. And for all of you who didn't win for this year's competition, no worry. We are going to see you again next year. And remember that losing is essential to anyone's success. The more you lose, the more you want to win.
Exactly. We also want to appreciate all of your efforts in joining all the competitions and events. Let's hope that today is a start for something bigger tomorrow. Now, ladies and gentlemen, we have come to the last session of today's agenda. But before that, let us hear closing remarks from Dr. Ing Aziz Boying Sitanggang as the chairman of the organizing committee. Dr. Sitanggang, the time is yours.
Yeah, thank you very much for the MC for the time given to me. Well, actually, I'm standing here on behalf of Dr. Ferry Kusnandar. He apologizes as he couldn't make it to deliver the closing remarks as he has something else really urgent needs to be done. Late afternoon to all of us, keynote speakers, moderators, all conference participants, all participants for food product development competitions, graduate students research paper competition, and of course, all the winners. Although the announcement of the winners this year seems like a bit lame because it is virtual, but it doesn't change the meaning of being the winners. Good. Ladies and gentlemen, the Department of Food Science and Technology, IPB University, focuses itself to produce graduates who have competencies in food processing materials, okay, into safe, quality, and healthy food products at industrial scale. Since it was opened in 1964, Food Science and Technology, IPB University, has been nurturing graduates whom are capable to work in various positions or fields in the national or international food industries, government agencies, or as successful food entrepreneurs. And probably, as you know, Department of Food Science and Technology is considered to be one of the oldest study programs in the field of agricultural-based food processing, accredited A by the National Accreditation Body of Higher Education. And this department is also internationally accredited by the American Institute of Food Technologists, IFT, since 2010, and the International Union of Food Science and Technology, IUFOST, since 2013. So this department has distinction of being the first food technology study program outside of North America that is recognized by the IFT with the status of developed in managing education. So, ladies and gentlemen, students, dear colleagues, fellows of food technologists and food scientists, in this globalization era, food, health, and nutrition have been considered playing vital roles for public health. I think it is well reported that we have seen an increasing trend of non-communicable diseases, NCDs, as also presented by Professor Chin Kun Wang, one of the invited speakers. According to WHO, every year NCDs kill about 8.9 million people across WHO Southeast Asia region. So it's really large amount of number. From the report of Riskesbas, especially in Indonesia in 2018, the trend also increases. We have to pay attention and concern about this, and we have to think about on the perspective of how the food systems can be a powerful tool to prevent non-communicable diseases. Food, health, and nutrition is a very complex system. Combating malnutrition or double burden of malnutrition, in particular for NCDs, requires collaboration and cooperation at national, regional, or even global level. We, as food technologists and scientists, can work together. We may have visited our dietary guidelines, and evaluate what kind of patterns that effectively reducing the NCD is. Of course, this is not a single cause, and the causes will be complicated by other influencing factors such as availability, accessibility, affordability, habits, and behaviors of the consumers. In addition to this, we have heard a very good news last week that the World Food Programme, WFP, has received a Nobel Prize of Peace as a recognition that WFP provides support to assure the sustainability of food consumption, especially to the countries and communities that are in wars, conflicts, natural disasters, or no access for food due to failures in food production. The sustainability of food production is affected by climate change, environmental degradation, loss of biodiversity, and human interference. The complexity also arises when sustainable food consumption is associated with sustainable food production, and later to sustainable, healthy food. We have to be aware of this, and I believe this is also one of the reasons we gather here on the 6th Food Ingredient Asia Conference 2020. Within this international seminar, through technical sessions and of course workshops that have been done, we are expecting more research findings can be disseminated, shared among food scientists and technologists. Hopefully, this seminar can be considered as a platform where the academicians, government institutions, and private companies can establish networks for future collaborations. With this occasion, we would like to sincerely convey our gratitude to all the speakers, all the moderators, and all participants who have been participating in this conference. And especially, we would like to convey our gratitude as well to PT Indofood Sukses Makmur Tbk for supporting the event Students' Day, especially for sensory workshop and student food product development competition. To end this speech, after finishing this international seminar, allow me to give all of us take-home assignments that might be solved in our own institutions in relation to the future challenges on food science and technology, health, and nutrition. Let me read the points. First, how can we provide affordable and balanced nutrition to the malnourished to achieve nutrition security? That's the main point. The second point, how we can eliminate material waste in production, distribution, and consumption to achieve food security. And lastly, how we can start to adopt healthy and sustainable food consumption. Please bear in our mind that further highlight should be put onto the aspects of reformulating food composition and modification of processing so that balanced nutrition, convenience, and consumer acceptability is provided at low cost. Thank you very much for your attention, and I hope that all of us have had the best experiences while participating in this international seminar. Once again, thank you very much, and see you again at SIVA's International Seminar 2021 at IPB International Convention Center, Bogor. Cheers and have a good day. Thank you.
Thank you very much for the very warm remarks and also the take-home assignments from Dr. Sitanggang. Let us proceed to hear the closing remarks from Professor Dr. Umar Santoso as the President of Indonesia Association of Food Technology. Time is yours, Professor Umar.
Thank you, Rosalia. Good afternoon, ladies and gentlemen, especially Professor Wang, Professor Lilis, Moderator Professor Ratih, all of the participants, committee member, and ladies and gentlemen. By finishing this session, plenary session 2, by Dr. Wang and Dr. Lilis, the session is very interesting, very worthwhile, very valuable, I think, about functional food, and Prof. Lilis about prebiotic, probiotic, and symbiotic. Prof. Wang about the functional food. Process development. And by finishing this session, and so today's webinar has been finished. And before closing, I would like to thank all of the speaker, moderator, and participant. And also congratulations to the winner just now announced for the best oral presenters for graduate student research paper competition, best product, and so on. Yeah, congratulations for your achievement. It's very proud with this achievement, and I hope we will have the better effort, and so who not get the winner will be the winners too. Yeah. Ladies and gentlemen, I think not only today, because tomorrow actually will be one agenda, that is halal workshop, but the webinar is offered today. I would like to thank also the committee, the chairman, Aziz, Dr. Aziz, also to CFAS Center, IBB, to Department of Food Science and Technology, IBB, and all, I think, for the sponsorship and to make this webinar successful. And so, thank you also to Master of Ceremony Rosalia, and also Candice Iskandar, and host many person involved. I think. Thank you so much, and we hope we can meet again in the next chance, better condition. We hope COVID will be over soon and become back to the world. Yeah, I hope you are healthy condition, and now the webinar officially by saying praise to God, Alhamdulillah Rabbil Alamin, the webinar is officially closed. Thank you. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh. Thank you.
Thank you, Professor Umar, for your closing remarks. Unfortunately, this is going to be the last agenda for today's session. Ladies and gentlemen, we want to give our biggest appreciation for participating in the 6th Food Ingredients Asia Conference Day 2.
Once again, congratulations for all the winners. On behalf of the organizing committee, we would like to thank you for your participation. Hopefully, we may see you on the 3rd CFAS International Seminar 2021 and 7th Food Ingredient Asia Conference on 2022.
Yes, and for the participants who have registered for tomorrow's session, we are expecting you exactly at 9 a.m. As our last gift, let me read this freshly made poem to you. We regard ourselves as experts in food, solving problems in all likelihood.
But have we truly ever understood to take care of this earth our ancestors stood?
Thank you, ladies and gentlemen. Please stay at home,
wear your mask, wash your hands, and stay safe. Bye-bye.
Bye-bye.
Thank you very much. Dear participant, well, it's officially closed, but I would like to give extension of the announcement that tomorrow there will be halal workshop. Okay, it will be started exactly 8:30 a.m. So those who are really interested to participate in this halal workshop, you may also join. Of course, you just click the link that we have provided in the technical guideline. So although it's actually a paid seminar, but it's okay if some of you who are really interested, you may join as well. So don't worry. Okay, so we expect that you may join tomorrow. Thank you so much. Have a good day. Terima kasih Prof. Umar. Thank you so much. Ada Bu Lilis di sini, Prof. Lilis, Prof. Latih. Thank you so much.
Ya, terima kasih sama-sama.
Bapak Ibu
Thank you.
dari PADPI, terima kasih. Terima kasih adik-adik mahasiswa, GSRPC, FPDC, Panitia, FPDC. Thank you so much. You are the best, ya, for holding this competition. Dan semua Bapak Ibu moderator yang ada di sini. Terima kasih. Terima kasih yang terakhir kepada MC kita, ada Candice dan Hanim. Thank you so much.
Terima kasih Pak Aziz, luar biasa.
Makasih juga ada Bu Nuri di sini sebagai Director.
Oke, see you again, Bu Nuri.
Coba boleh nggak di-highlight Bu Nuri, Pak Umar, gitu. Tolong di-highlight dulu biar kita ambil dulu foto sessionnya. Host, please.
Boleh. Tadi saya sudah mau live tapi dipanggil lagi. Ya,
tolong berikan senyum terbaik dulu, Bu Nuri, Prof. Umar.
Oke, please.
Please, host.
Ada Pak Soekarno juga nih, Pak Soekarno.
Oke, thank you so much.
Terima kasih.
Terima kasih, Bu.
Terima kasih.